Welcome, I'm Emily Gates. I work on partnerships here at Transit. Most of you know Transit, but for those who don't, we are an app for transit riders. In more than 200 cities worldwide, we focus mostly on the US and Canada. We connect riders with real-time information and allow them to purchase fares. We partner with more than 75 transit agencies, fare payment providers, and new mobility operators. That includes the MBTA as their endorsed app. At our core are public data standards that help us put together a seamless multimodal experience to help riders get around without their car. Now during the pandemic, we're focused on working with transit agencies to get up-to-date information to riders, assisting agencies by providing data and analysis to help them provide critical services, some of which we publish publicly on our website, and integrating crowding information into the app in as many cities as we can. Which leads us to today's Q&A. During the pandemic at Transit, we found ourselves in a unique position to help answer the question, how do we help riders concerned about physical distancing? Today, we're going to hear from the MBTA, who just last week launched real-time crowding along major bus lines, Trapeze, who provides this important data through their on-vehicle technology, MobilityData, who is working to bring together a data standard for the industry, and I will be speaking for the user perspective on crowding representing Transit, sharing results from 6,000 people who are riding and not riding transit about how they feel about crowding, what information they want, and how it might change their behavior. We hope it'll help to inform your work, and hopefully the Q&A can help you learn from this unique group. Today's Q&A will be led by members of the MBTA, Trapeze, MobilityData, and myself. Jessie Richards is a product manager in the customer technology department of the MBTA in Boston. She will be discussing how the T is staying rider-focused when it comes to crowding. I'll talk about what other agencies are doing and the results of Transit's user survey. Nate Reynolds is the product director for the Intelligent Transportation Systems products at Trapeze. He spent his entire career with these products at Trapeze, from working on implementations with agencies to enterprise architecture of the products, and ultimately now to product management. He will be discussing the APC technology and how agencies are using it to produce this data. Marla Westervelt is in charge of community and partnerships for North America and Pacific for MobilityData, formerly Global Data Policy and Business Development at Bird, and the former head of research at the Office of Extraordinary Innovation at LA Metro. Marla will talk about the standards for this information. At the end, I'll moderate a Q&A. Please use the Q&A button at the bottom of your screen to submit questions and tell us about what your agency is doing and what you're thinking about in terms of crowding. In the coming days, everyone registered will receive a recording and a summary of our analysis. Finally, before I hand it over to Jessie, many people are registered from all across the globe. If you want to talk with us about crowding data specifically for your city, contact us at partners@transitapp.com. Now, take us away, Jessie.
Thanks for the introduction, Emily. So everybody, I'm Jessie, and I'm going to talk to you today about the MBTA's journey with crowding information. I'll walk through the research that laid the foundation of our rider-focused approach, the data that told us what was possible to share, and the design efforts that are helping us clearly communicate to riders. Next slide, and the next slide. So we're all living in a world where right now we're being told to keep at least 6 feet apart, and that presents an obvious predicament to a public transit system where people are packed in like sardines. So our department was ready to pounce on this issue, excited to tackle the challenge. Let's put crowding information everywhere, screens, apps, our website. Let's use machine learning. Let's get it out the door as soon as possible. But first, we had to take a step back and ask, are we solving the right problem in the best way we can? There's really no such thing as the right problem, but with all of our excitement about sharing crowding information in the age of social distancing, we needed to understand, is this the information that riders care about? So our goal with crowding information was to help riders prepare for their trips and do so in a way that will outlive the pandemic, whenever that may end. So cue our initial research effort. We put up a survey on our website, advertised it on screens, reached out to local unions and hospitals and accessibility advocacy groups, and we got more of a response than we even could have imagined from people all over the greater Boston area. And the majority of people said that they did feel crowded when riding the T. And we learned that timing is the most important factor in decision-making for riders. When there's a crowded bus and you're early for work, you mostly want to wait it out for the next bus. But if you're set to be on time or late, you risk it and take that bus anyway. And for this reason, we also found that prediction information is still more vital than crowding. You first want to know when the next bus is coming and then how crowded it'll be. It's icing on the cake, not essential. We also heard from riders that crowding data is only as helpful as it is actionable. And there are generally two kinds of riders, those who have the privilege of flexibility in their travel time and those who don't. And while most riders may try to wait it out for the next bus, we heard that very few would or even could change their plans. Most people taking public transit right now are essential workers, living in historically underinvested communities, and they're in potentially dangerous situations every time they ride public transit. Deciding whether to take this bus or wait it out means risking getting sick or getting fired. And as we worked from the comfort of our homes, we found it important to remember who we're serving and always remember that they're the experts of their own public transit experience. So riders told us that they want two kinds of information. They want real-time data about crowding, and they also want information about historical trends. And we want to provide real-time information to prepare people to make decisions while already in transit, and trend data to allow those who can be flexible with their trip alter their timing so the system isn't as crowded when it doesn't need to be. Unfortunately, we aren't able to serve both kinds of data for all modes. So let's talk a little bit about how and where we're getting that crowding data. So we have differences in existing technology on our bus and subway, which presented us some challenges. And we had to collaborate with external and internal partners to get access to even any crowding data. And then we undertook a huge effort to understand and ensure the accuracy of our bus and APC data. So many of you may know what APC data is, but for those who don't, it's automated passenger counts, and Nate from Trapeze is going to touch on more on these later. So we have this technology on most of our buses, but we don't have APCs on any of our rail vehicles. So there we turn to AFC data from our automated fare collection system, where we see how many taps are recorded at gated subway stations. So real-time data is only available for the bus, and this APC system was never meant to be real-time. We're reading this data from devices over a radio network that can barely carry any data. And because this data is the source is all cobbled together, none of it was completely out of the box, and we've invested a lot of time and effort creating a custom solution and checking the accuracy. So data wizards in our department have automated a process to take the raw APC data and put it into one of these crowding buckets, assessing the level of crowdedness in real time. And we decided on these buckets based on design, and I'll talk about that later. So when we sample data from buses on our most crowded routes right now, we put them in the right bucket about 80% of the time if we allow for some acceptable error, which means that we're overcounting riders instead of undercounting them. And with the help of a fellow department at the T, we created a Tableau dashboard you see here to help us keep track of what our real-time feed says versus the actual counts. And we get the actual counts of passengers by doing manual spot checks. The security department at the T set us up with access to cameras aboard the buses. So people on our team go in and count riders on a particular bus and compare that to what our real-time feed says. And we've done this about 400 times. It's important that when launching this data, the information was good and that we were giving the information to those who could benefit from it most, riders on crowded routes. So we sought out the routes that were had the most instances of full buses, and we looked into whether or not they had usable data. And you can see in this table that 2 of our most crowded routes actually don't have usable data, and that's a problem for us and our riders, but we're working on it. So we're prioritizing routes that we know are full most often, and we looked at how often the APC data was being correctly categorized by our algorithms with some acceptable error, and we decided to launch this in batches. And so once we knew the data could be accurate, our designers thought about how we might want to communicate this. And we knew that when solving this problem, language is important, the design elements should be consistent, and that we needed to continue to include riders. So almost all riders need to be able to make decisions quickly. Riders may not be English proficient, or they may not be able to see colorization. So we kept the language short and simple. We're using a color scale to help communicate urgency, and the use of people icons help visually convey the information to those with limited English proficiency or color blindness. We also used a software called Userlytics that allows us to conduct unmoderated user testing, both digitally and remotely. And we showed riders the schematics you see here, and we asked them to match the conditions to the descriptions provided. We wanted to know if the language that our content and design teams had come up with was, if it would resonate and if it was strong enough to convey the risk. So it turns out that our team's instinct was right, and that is actually how we decided on breaking from the GTFS real-time spec and go with our own buckets of not crowded, some crowding, and crowded. So on e-ink screens, when there was no space for words about crowding, we wondered if a screen would need a legend. So we did more testing in userlytics with riders, and we ended up finding that they actually could understand what we were trying to communicate without a legend. And now crowding information is live on these e-ink screens, pages on our website, and in the Transit app, all places that we know riders are already looking for real-time information. So going forward, we're going to continue to collect feedback about this feature as it's out in the real world and iterate if and when necessary. We're also going to work with our system-wide accessibility department, as they believe crowding information will be of particular interest to riders with disabilities after the pandemic. And we're going to move forward on making real-time information more accurate on more bus routes. Thanks in advance to Nate and Trapeze for all the tweaks they're helping us with here. And we're also working on getting historical crowding data for all of our heavy rail lines. And in the end, we hope that all of this work will help riders feel more informed when facing a transit decision and feel safer taking the T. Releasing crowding information was a huge effort, and the work I highlighted here wouldn't have been possible without Akira, Ashley, Ingrid, Meg, Miles, Paul, and a slew of our other colleagues. And I would be remiss to not mention them. So thank you for listening.
Thanks, Jessie. As a reminder, I'm Emily from Transit, and I want to spend a few minutes talking about what other agencies are doing in the space and how our users feel about crowding. In March, we went live with 15 agencies crowding information, the largest being Transport for New South Wales in Sydney, Australia, but also including Pittsburgh, Staten Island Express buses, and Akron, Ohio. 3 months later, we have 30 plus agencies. We just added the MBTA last week, thanks Jessie, and we are adding more each week. We had internal design meetings about whether to accommodate the entire GTFS RT spec or what to do when an agency provides you with only a subset of available values that don't necessarily align with the spec, but as Jessie showed, may reflect significant user research. We're really grateful for the work that the T did in helping us with this. And we looked at whether to show percentage-based crowding or raw rider counts or text descriptions of crowding or a combination. As we brought more agency feeds into the app, we realized that as an industry, we have not yet coalesced around a single source of truth, and that we were using a standard that was built prior to the pandemic when crowding meant something entirely different than it does now. After the first few weeks of displaying crowding, we wanted to understand how this information could be more useful to our users. So we ran a survey across 6 markets. Most of our responses came from Toronto and Vancouver. Surprise, surprise, we're a Canadian-based company. Woohoo, Canada! We picked cities small and large, some of which already had crowding information, such as Akron and LADOT, and some of which were just an interesting place where we have strong agency partners who had an interest in displaying or learning how to display crowding information in the future and asked for our help. What did we learn? High level, we learned that ridership isn't going to return all at once, that app users will return to public transit gradually and mostly around when public health officials give the all clear, and not just when the restaurants open down the street, as well as when a vaccine is available. What we're measuring here is a feeling of comfort, which is influenced by who you are and what you have access to. We try to define that feeling by asking whether users had access to a car. If you have access to a car and you're a user of our app, then it's likely sometimes, at the very least, you use public transit not out of necessity, but because you want to. 61% of people that had a car are choosing not to ride transit right now. Also, among people who aren't riding transit at all at the moment, they are disproportionately working in non-essential occupations or are unemployed. We asked our users to tell us at what level crowded their vehicle would be in order for them to feel comfortable getting on the bus. We asked both for before COVID-19 was in place as well as today. Not surprisingly, people are feeling that there needs to be a lot more space on their vehicles for them to feel comfortable now than before COVID. This validates the approach agencies have already begun taking, like what Jessie spoke about with the T, but it also shows that the act of limiting occupancy on vehicles has met the moment, at least in terms of providing passengers greater comfort to ride again. We wanted to get a sense of what people would do if faced with a too crowded vehicle, especially in the context of urgent travel versus more discretionary travel. If it was urgent, slightly more than a third of our respondents would choose another mode to get where they were going. About a third would wait for the next vehicle, and a little less than a third would board that vehicle anyway, despite being overly crowded. If users had more time, more than half would wait for the next vehicle, indicating the importance of knowing in real time each vehicle's capacity. Note, it's less about displaying crowding information and more about making sure there is sufficient service on the road so that riders aren't faced with a bad choice of taking a more expensive, different mode or not participating in a needed activity or being late. Also, we asked users whether real-time occupancy data would change their riding habits. The majority of users responded saying that knowing real-time occupancy would help them plan differently. 30% of users say that if they know the information before they go, they will ride transit more often. This can be a tool in the recovery toolbox as we try to get people riding again when and where it's safe to do so. Finally, we found that when asked what kind of information would cause users to ride public transit more often, riders valued real-time occupancy over access to historical crowding data or crowdsourced information. This helps us to inform what's next, where transit is examining how to examine historical crowding levels, potentially utilize crowdsourcing where agencies aren't able to offer real-time levels, and thinking about predictions for crowding information, and most importantly, how to display all of that within our app in a user-friendly way. Agencies. The best way to get data into transit is through your existing APC providers. We've got data from Synchromatics, NG, UTA, Clever Devices, Init, you name it, we got it, already in the app. One of the vendors that's been doing a lot of work in this space is Trapeze, and next you'll hear from Nate to talk with you about the technology itself. Nate?
Thank you, Emily. Hello, everybody. My name is Nate Reynolds. I'm with Trapeze Group. I'm going to be talking about APC technology and impact of boarding behavior, ensuring you're getting quality data and integrating this data into your system. As many of you know, Trapeze partners with agencies for technology solutions in almost every department within transit, as you see across all those little bubbles. But today the discussion is just around two of our suites. One is the Traveler Information Suite that includes rider-facing apps and tools that leverage crowding data. But the other one I'm here representing is the Intelligent Transportation System suite of products, more specifically the Transit Master product that I'm responsible for here at Trapeze. Transit Master is the ITS solution in place with the MBTA, so I'm excited to be here as part of our partnership with the T. So I was asked to speak a little bit about the source of crowding data, and I want to start with a quick overview of the two main styles of automatic passenger counting sensors and the impact of boarding behavior on them. In this first picture, we see an example of what I'm calling a beam sensor. This type of sensor operates in pairs installed either side of each doorway and has infrared beams connected between them. The beams are broken as you walk through the door, and the order of the beams being broken indicates to the sensor someone getting on or off the vehicle. The critical aspect of these sensors, though, is that line of sight is required between the sensors for them to function well. Next slide. So it can struggle at times in the world of real-door boarding because the nature of the technology and the need for line of sight between the sensors means it doesn't always handle bidirectional flow of people within a single doorway very well. So if those sensors can't see each other because of another person being in the way or something being in the way that blocks the one sensor from viewing the other, you're going to miss counts. And occasionally these errors in counts are quite large, particularly if there's a lot of crowding around the doorway or something like a bag is blocking the sensor. The other style of sensor is the overhead style of infrared or optical, basically a camera sensor. This type of sensor is more expensive, but it is more accurate, and it can handle these scenarios we just mentioned a bit more gracefully. Since it is overhead and has a bird's eye view of the action going on in the vehicle, it doesn't have the same challenges of a beam counter when it comes to bidirectional boarding and experiences less of these big anomalies in counting due to some type of blockage. In some sampling that we were analyzing, we saw about a 5 to 10% better real-time accuracy from the overhead sensors compared to the beam sensors. Now that we've covered the styles of sensors, I want to talk about the use of APCs. So previously, the APC's primary use case was historical ridership reporting and TD reporting. And for this historical use case, you have post-processing that can look back at the whole day's worth of data to flag bad trips or blocks of ABC data and leverage statistical averages as well as sampling data to improve the accuracy of ridership data for your reporting purposes. But when it comes to real-time, accuracy of passenger load is quite variable. You can see drift and accuracy as counting errors on each trip add up and compound throughout the day. Real-time ridership doesn't have the benefits of hindsight that we have with our historical data and isn't using the statistical averages that the post-processing tools are able to use. That's not to say that there's just nothing that you can do to manipulate or improve real-time counts. There's still rules in place to be able to adjust passenger load in real time to prevent negative loads, including points where we can reset passenger load so that it gets back into sync. And there's also manual overrides to set the vehicle occupancy to empty or full to address anomalies or drift in accuracy seen in service. The point here, though, is just that accuracy levels you get from your historical ridership or NTD reporting just aren't quite there yet from a real-time perspective at the moment that you get from some of the elevated accuracy. Next slide, please. So while real-time isn't as accurate as historical ridership data, using this data in real time makes it even more important to take steps to ensure your data is as good as it possibly can be. APCs automatically count, but they aren't automatically maintaining themselves yet. So just because the vehicle has APCs and is getting data, that doesn't mean it's good data. So there's a couple of basic checks that should be done regularly to identify problem counters or vehicles. Comparison of your on and off counts is the main one. So in theory, your ons and offs should be about 1-to-1, unless you have some stragglers in the garage at the end of the day. So you're looking for variation of your ons and offs to be about between 10 and 15% or more. And when you see that variation of your ons and offs more than 10 to 15% regularly, that's a vehicle you want to flag to have looked at by maintenance. The other main check that can be used is looking for scenarios in which a door isn't getting counts, like all of the counts are coming from the front door versus the rear door. Obviously, this is great in normal times when you've got boarding across both doors, but if you are an agency that's using rear door boarding only, this check isn't quite as useful. Proactively identifying and fixing issues is critical, along with those checks I mentioned. Including a small activity for APCs into regular preventative maintenance is a great way to keep the fleet healthy. So during a PM cycle, having a tech just do some sample counts in each door to make sure they're counting properly, wiping down the sensor, particularly for beam sensors, are two ways that can help your health of your APCs drastically. And if regular maintenance of your APCs hasn't been happening in your fleet, then there could be a lot of work ahead to address some of those problem vehicles. But once you have the fleet in a healthy place, it's relatively minimal effort to keep it healthy just by doing those small things that I mentioned. All right, so now that you have healthy APCs, that data can be provided downstream to passenger information applications via GTFS real-time, like the Transit app. And Marla will be talking a little bit about those different fields within the specification. Or data could flow through our own native integration with the Trapeze Travel Information Suite that you can see on the screen right there from our partners in Tucson. The one note here is just regardless of the solution, setting up your vehicle capacity based on the current operations is critical to having the right occupancy status information flowing downstream. So if you're only allowing 10 people or 15 people, however many people it is on each vehicle type, it's critical to have that set up properly beforehand. Next slide. So to close out my 5 minutes of fame here, boarding behaviors can impact accuracy, particularly with the beam sensors. Make sure you're setting up your capacity information correctly to get the right occupancy status information flowing downstream. And really critically, make sure you're maintaining your sensors proactively to get quality data in the hands of your passengers. Thank you for your time.
Thanks so much, Nate. Now Marla is going to talk about the standards, but before Marla gets into that, I wanted to remind the attendees that they can ask questions directly in the Q&A button at the bottom of your screen. Take it away, Marla.
Thank you. Well, first I want to say thank you, both Jesse, Nathan, and Emily, for all those really exciting presentations. As a person sitting in a standards body, it's really invigorating to hear all of this work that's getting done on the ground. So let's go to the next slide. So first, I want to introduce myself. My name is Marla Westerveld. As Emily mentioned, I am the lead for community and partnerships for MobilityData for North America and Pacific. I've worked in the transportation industry my whole career, and I'm extremely passionate about figuring out how to build effective frameworks to enable the transportation industry to leverage technologies. I've done this at previous roles, including at BIRD, at LA Metro's Office of Extraordinary Innovation, and at the Eno Center for Transportation. Next slide. So a little bit about MobilityData. It's a relatively new nonprofit that is based in Montreal that seeks to create interoperable transportation systems through the development of standards. Specifically, we govern the GTFS standard, which is the General Transit Feed Specification, and the GBFS standard, which is the General Bike Share Feed Specification. Next slide. So standards are extremely important because standards allow you to scale. So for example, if there weren't any standards and Jessie wanted to share these data with Transit App, she would have to create a new means with Transit App to enable that. She would then have to go reach out to other potential consumers and say, hey, will you consume data in this way? The standardization process makes that simple and says, here's how we're going to share it, and this is open, and everyone's able to buy into it. And it also prevents vendor lock-in. So we've been thinking about occupancy and the standard for quite a while. In 2015, we introduced a experimental field into GTFS real-time. An experimental field means it hasn't fully been incorporated within the standard yet, but it's out there and we want people to test it. We want them to give us feedback so that we can go through the process to actually make sure it is part of the official standard. We also, at some point in the last few years have introduced GTFS Occupancy Extensions Draft, which is a proposal for static data to include within static GTFS to have historical indications of what occupancy is typically throughout the day. But to date, or not today, prior to COVID, there were very, very few producers of either of these types of occupancy data. It was challenging to figure out how to go through what Jessie just went through to figure out how to get these data and clean these data to provide within the specification. And there weren't many consumers of these data. Next slide. But then the world changed, and all of a sudden, I think globally, we realized that this was actually a priority. And things started happening both in the specification and on the ground. Within the specification, we started having a robust conversation on GitHub through both issues and pull requests to discuss, are the experimental fields that currently exist the correct fields? Do we need to create a new way to talk about occupancy? As a reaction to those conversations, we added a new experimental field to say, you could count the number of people through enumerating by saying, this vehicle is crowded, this vehicle is not crowded, this vehicle has a few number of people. Or now you can have the option of saying, throw that out, use a different field, and give us the percentage of crowdedness. And you can align both of these things to what the current operating regulations are for COVID. And the industry also implemented, as has been discussed. So the number of producers dramatically increased. The consumers also dramatically increased, as demonstrated by transit. And hardware and software vendors have also started aggressively investing in making sure that we're able to facilitate this type of data exchange easily. Next slide. So where do we go from here? Here at MobilityData, we are super, super excited that this conversation is so robust right now, and we want to continue to encourage data producers and consumers to generate these data and talk to their vendors to also ask them to support the generation of these data. This interaction allows us to more effectively facilitate community discussions and figure out how should we actually talk about the number of people on a vehicle, what is the clearest to the end consumer, and what is the clearest to a company like Transit App when they are translating these data into their app. We are excited to also work with the community to define some other challenges that I think have been alluded to on this call so far, such as how do you make sure you're actually counting the number of people in the vehicle correctly and consistently across agencies? And with all of these conversations, we are excited that we'll be able to soon move forward and actually finalize occupancy as a permanent field within the specification. Thank you.
Thanks, Marla. Now we're going to move on to the Q&A portion of today's discussion, which I'll be moderating. We received several questions in advance and have picked a couple from that group of questions to start with. I once again encourage you to ask more questions within the Q&A, and I will be asking them and then handing them off to various members of this group to answer, including myself, awkwardly in some cases. So with that, we got a question in advance from Christine. This one I believe is directed towards Jesse. Jesse, how do you effectively socially distance on a bus when your passengers cannot comprehend what that means?
The first thing that comes to mind actually when I'm thinking about this is some userlytics tests where we were able to like show people these schematics and they could talk through like how they decided whether or not the bus was crowded. And so we could hear people talking about like how their like living situations, if someone was living with someone who was elderly, they would not take the risk of getting on the bus. And so I think social distancing actually means, I think Emily, you touched on this a little bit, it means a lot about your current circumstance. And so as a person, you know, I don't know, how can anyone effectively social distance? I think that's like a larger question for, you know, everybody, but I also think that the T right now is not, we are not strictly enforcing social distancing. I think that is a really hard thing to do as a public transit agency. We're just trying to give people as much information so they can take action on their own standards of social distance.
You're not handing out hula hoops on the train?
Unfortunately, no.
Well, keep that in mind as a, you know, official recommendation.
Got it. Yeah. Okay. Thank you. Thank you, Emily.
The next question we got in advance, which came from Selena. How will we apply an equity lens with crowding technology? I am gonna try to answer this question, but please jump in if you also would like to contribute. When we've been thinking about equity and applying it to crowding technology, it's really a question of whether or not you can afford to be flexible, as Jesse said, with what bus or train you take to work. So even with real-time crowding information, you have to have some flexibility in both the mode you choose, but also, you know, if the one that's coming towards you is extremely full, hitting up the next one could, you know, mean that you're 2 hours late to your shift, or that you're on a vehicle that has been impacted by service changes to the point where you're waiting another hour or so to get on that bus or train. And as Jesse mentioned, in the long term, this information can be really useful for people who use wheelchairs. If your bus is crowded, it is likely that a wheelchair user will not be able to get on because they have even more limited space than people who have use of their legs. And it's going to be important to maintain and expand upon even in the absence of COVID-19. Getting this information in the app is a good way to ensure equity because, as previous surveys have shown, poor, Black, brown people disproportionately use the bus and are riding right now, and using apps to help get them where they're going. So we haven't talked about it much, but it is something that some agencies are thinking about, which is mostly outside of the US, reserving a seat with a smartphone. We don't think that's a great solution from an equity lens. I think there's more implications that come from getting advanced access to this information. It's the reason why Jessie and her team put together e-ink readers at all of the bus stations for those who don't have access to smartphones. So that is going to be really important to keep in mind as we go forward. So thanks for that question. The next question that we received in advance is for Marla. It's from David. Marla, who is using what standard right now? How has implementation varied, and should we be modifying the spec to reflect these implementations?
Yeah, good question. So this is really the long conversation that is happening on GitHub, which is which field should I use and why? And as a reminder, the current fields that we have for occupancy are a enumeration, which is a list of, the vehicle is crowded, the vehicle is not crowded. And then there's also percentage, which, goes from obviously 0 to 100%. And both can be aligned with the current operating regulations. And based on robust discussion, we've determined it depends which specification you should use, and it's not clear yet. And so I think that this is an area of learning for the entire industry where we can take this time and we can experiment, and MobilityData is looking forward to intaking that information to determining what makes most sense to codify within the specification, and also, making clear and alternative resources to say, here are the best practices and why, and here's how you communicate most effectively with your customers. But all that to say, this is an experimental part of the specification, and so we're working with the community to figure out how to move forward.
Yeah, you really implied that as part of your presentation, that you started in 2015, very experimental, and then people kind of put it on a shelf. I'm glad that we've picked it up off of that shelf and are talking and discussing through all of this. We have another question coming in for Jesse from Katie. How long did the bus crowding project take from conception to rollout, including all testing?
So we started this work, I'd say early April, and it's ongoing. As I said, we only launched, I think, about 7 routes last week, and then we're hoping to launch another batch of around that same size this week, and then continue to roll out on a bi-weekly basis as we can try and get accuracy up on some other routes. So yeah, so it's ongoing, and so it's been taking us, I guess, about 3 months now. And we're, not only bus, but also with rail expanding, we're thinking these efforts are probably going to take us into the fall.
Would you say that this is a top priority for the MBTA in terms of responsiveness to COVID?
Yes, I would say that this is a lot of the people that worked for this effort in our department and in other departments in the T kind of dropped some of the work that we had originally planned on doing, and prioritized this above all of that. So I'd say most of those people are spending the majority of their time working on crowding efforts.
Got it. I've got another one for you, Jesse. I hope you're ready.
Okay.
Chris, does the MBTA plan to integrate vehicle crowding data into real-time dispatching operations and service planning?
Yeah, so we actually, we created our own app called Skate that bus operations is using, and we are actively integrating crowding information into that. So, and we also worked a little bit with operations to make them a full bus report so they could keep track of which routes were getting the most full. And so, yeah, so we're actively working with operations, and I think I have a little bit less insight into the service planning part of it, but yeah, we're making that data available and actively talking to all the places in our organization that might need it.
Nice. For Nate from John, what is the typical cost of side-by-side APC sensor versus overhead sensors?
So I mean, the cost is obviously going to vary vendor to vendor, and depending on whether or not we're like the vendor's doing installation or you're doing the installation. From off the top of my head, I believe like the typical cost is going to be anywhere in like the like $2,000 to $6,000 a vehicle, roughly, off the top of my head.
You mean you can't just tape a cell phone to the inside and cause a Raspberry Pi it?
Next year, yeah. Next year.
Exactly. Cool. Thanks, Nate. I have a question for Marla from Steven. Are there standards for sharing historical data rather than real time being developed?
And by historical data, you mean historical occupancy data, correct?
Yes.
Okay. So for historical occupancy data, we are having a conversation within the specification about having a field and static GTFS to report historical averages over time to say, on average, at this time of the day, we have X number of people in the vehicle. But there are also a number of projects happening outside of the scope of mobility data right now, such as GTFS Ride, where the Oregon Department of Transportation is developing a specification for historical ride reporting, which then could be used as the tool for occupancy. I believe that there has also been discussions of using the mobility data specification in the world of transit. All of that to be said, I think that this is an opportunity for clarity amongst the community about what we are looking for, and which of these tools, if any of these tools, best fit our needs.
Got it. This one's for me from Ryan. Are there ways to automate this data via the app or crowdsource it rather than rely on agencies to provide crowding information? We are currently in the process of evaluating what we can do with crowdsourced information. So far, it is more challenging to infer that information out from the number of people who are riding along particular routes. Mostly from a, oversampling on certain routes, undersampling on lots of routes. What does it mean to have 2 people on the bus riding at the same time in terms of crowdedness? Does that translate to 20 people? Does that translate to 10 people? So it is something that internally within transit, we are working on trying to figure out, but we believe that the most important next best step is to think about expanding upon the information we are currently receiving from agencies to include things like predictions for upcoming trips. So it's less about getting access to more real-time beyond what we can already provide. We are also focused on what the look and feel of future trips will look like based on historical information. I have a question for Nate, possibly Jesse, we'll see. From Bethany, can we share this information if we don't have APCs on all our vehicles?
Yeah, from my side, I guess the information can be shared for whatever number of vehicles have APC data, can have that data shared out to the public. So absolutely.
And I can touch on it just briefly is, obviously since our subway, our heavy rail and most of our light rail vehicles don't have APCs, we're trying to think of just other ways that we can share information that may not be real-time crowding of a particular vehicle. And just more looking at sharing historical trends with any kind of data that we can cobble together.
Yes, we understand that it's a little bit like crowdsourced information. If you've got it straight from the source and it's pretty accurate from you all, that's step one. The next step is entering the unknown and dealing with the uncertainty of those ones that are a little bit more challenging, but ultimately going to be worthwhile. For Jesse or Nathan again, from Francis, any thoughts on how to deal with rail, especially at stations that serve multiple routes or directions?
I'll say that we're actively thinking through this right now. I think our first focus is going to be on, just because I think the majority of riders ride in a similar pattern. And so sharing at just the route level may be useful for the majority of riders, but we want to serve all of our riders that we can. And so we're actively thinking through how do we get more specific and nuanced with that information.
That makes sense. And for my side, I guess we do support at passenger counters on like light rail and streetcar vehicles. And so that information will be shared just as it is for bus from our solution if that data is available.
Follow up on that though, you're not really focused right now on station level crowding information?
Vehicle level, yeah.
For Marla from Juan, how are COVID-19 and other emergency disruptions impacting the conversation on finalizing Service Changes 3.1 proposal? For context, this proposal will help transit agencies show on-the-fly changes to service stops, routing, and more in their GTFS.
So I think similar to the occupancy conversation, that service changes has also had increased urgency amongst the community in a way that we hadn't seen before. And that I believe is going to help us accelerate the conversation and put that into implementation. With that being said, as with all things within our specification, it's a partnership with our community. And service alerts do have a lot of moving pieces and barriers to implementation. And so we will be working into the community to figure out what do they need to help us get there sooner and help make sure that that is part of the specification.
Great. I look forward to, helping you with that in whatever way I can. I've got one for Jesse from John. Can you talk about the process MBTA took to implement and share real-time occupancy data? Was it an internal decision or priority, or was there external pressure?
I think it started with our own internal pressure. Crowding is something that even before COVID, we were thinking about. It just wasn't a priority because there were a lot of technical barriers to get through. And so now that it became, a public health issue and, that we thought it could be important to riders, that's when we started to prioritize. And that's also why we tried to do this research effort to say, is there any external want for this? And there is. And I'll say also, within internally, the research very much helped us talk internally about how and what and when we should be launching this data.
As a follow-up directly to that last question or last comment, were there any internal agency challenges to getting approval to releasing real-time crowding data? That question is from Michael.
I don't know that I would want to call them challenges. It's just kind of, generally, this went all the way up to the highest office at the MBTA, and there were discussions there. And so I think that the biggest approval, or the approval that we had to get, was just to say, are we releasing something that is accurate? Is this what people want? And basically trying to think about what kind of backlash would we get after releasing this, and trying to get ahead of that ourselves.
Thank you. I have one more question for Jesse from Simon. You mentioned that APC data is transmitted in real time via radio. Why not use Wi-Fi already on buses?
That's a good question that I actually don't fully know the answer to, but I trust the team that if radio's the way that they went, that is what would have worked the best. I think if I'm remembering some conversations correctly, that actually Wi-Fi isn't available on all of our buses, and I think that buses only get connected to Wi-Fi once they are in once they're at their garages. And so we don't have access to them in real time.
Yeah, and maybe to tag on to that, so we are doing some testing with the kind of Wi-Fi hotspots that are available on some of the T buses. So it's something that's being explored for the future. But yes, that is in process.
So we got a question from Alvaro that I'm going to attempt to answer. Some transit agencies are establishing policies setting bus capacity to accommodate social distancing. For example, Chicago CTA. CTA vehicle passenger standards are now approximately 15 riders on a standard 40-foot bus and approximately 22 riders on 60-foot articulated buses and in each train car. Is Transit App working with agencies adopting thresholds for bus/train capacity? If so, how is the display of a bus capacity/crowding level communicated in the app? So I'll start with the way in which we're speaking with agencies. Much like our conversations with the T around language, we are having conversations with APC providers and also agencies themselves, trying to get this information into the app, especially given that some agencies are using some portions of the GTFS standard and some are providing us with an API directly outside of the app. So with all of that, we are in the process of, because we have 30 plus agencies already as data in the app, we are designing a solution that is both flexible, that allows the MBTA to have the specific language that they wanted to use. Transport for New South Wales is also using specific language around this. We have developed our own language for agencies that have not expressed a preference. When we get APC information that seems a little bit stranger than we expect, we push back on the agencies and say things like, are you sure that you want to put this live to riders in this fashion, and make sure that the agency is really taking into account the customer's perspective when it comes to what users are seeing in the app. We are also planning on talking with and sharing the results of our user survey, not only with the agencies in the 6 cities where we ran it, but also with the other agencies that we are trying to get APC information from to help better inform their designs. But this has been much more agency-led, although occasionally we look under a APC vendor rock and find a whole bunch of feeds and put that information in there before speaking to the agency, and then we go back and try to validate it and help them come to sort of some conclusion about what they should be sharing. So I have a question for Nate from Doe, possibly with Jesse as well to supplement. You guys are a tag team today. To help with real-time correction of real-time derived occupancy from APC, in addition to the methods Nate mentioned, is anyone trying to also use systematic correction factors, i.e. by door and ons versus offs, developed using historical data validation? Also, not from Doe, it's from Doug. Doug, Doe, very similar.
So I'm not sure what other vendors are doing with respect to the systematic correction factors. I do think that, so one of the things that is an investigation for us is around kind of the 0 load points in the solution, and kind of incorporating those, but then also making that a bit more intelligent as far as not having to necessarily have those 0 load points be defined ahead of time, like in the schedule, but could those be defined based on what you see in historical data? So that is one of our kind of investigation tasks on the roadmap.
And I can answer and say that so a little bit of clarification of how we're using the data that we're getting from the APCs. We're actually not using the calculated passenger load. We're taking the raw on and offs at each stop and calculating our own passenger load, because right now actually Transit Master doesn't pass that information on to us in real time. So we're doing that calculation in our own software and handling our own rebalancing at the end of a trip.
Cool. To Nate, what hardware type and version was used for the MBTA? Are there APC hardwares the same for both vehicles like buses and rail? And yeah, I'm trying to translate the language, but basically, like what exactly hardware was used on the MBTA?
So Jesse, I guess you can correct me if I'm wrong, but I believe it's UTA passenger counters that are on board the vehicles. And then there's a couple of different generations of the Transit Master in-vehicle hardware There's a few hundred buses that are older Pentium DOS IVLUs, and there's some of our second kind of like last generation VI IVLUs that are on board the vehicles. And I believe, Jesse, you'd mentioned there's no APC equipment on the rail vehicles. The thought there was to be using some of the historical data.
Awesome. So starting with Nate, 1 minute, last final thoughts on APC and where you would like to go from here.
Sorry, I'm muting myself. No, so I think my main message here today was just that it's super important to be doing your maintenance of the APCs and be doing, what the MBTA did with spot checking to make sure you're confident in the accuracy levels and that you're giving out quality data to your passengers. At the end of the day, that's the most important thing when it comes to getting this crowding data out to the public.
Great. Jesse, final thoughts?
Sure. So I think the message that I would hope everyone would leave today is how important doing research with riders is. And so I think that's something that, transit, you obviously feels very important. And, not only doing some early research, but for us, it was really embroiling research into the process. So doing the early research, doing research before we launched, continuing to do research after, and really trying to understand people's perspectives and how we're serving them or not serving them. And making sure that we are trying to serve as many riders as possible, and especially the ones that are already at some kind of disadvantage.
Absolutely, thanks. Marla, final thoughts?
Cool. Yeah, I think that my final thought is, the implementation piece here is extremely challenging and the first step, but making sure that we have a really clear standard that will allow us to scale this across many different applications like transit and across the world is really important. So we encourage you to come and have conversations with us in our community, either on GitHub, with me personally, with our developers personally, so we can understand what your needs are and we can effectively reflect that within the specification to hopefully help people in this incredible time of need.
Thanks. My final thoughts are encouraging agencies to reach out to their APC vendors to make this data available in public. And we encourage any and all creative solutions to getting this information in front of our riders, but mostly in front of all public transit riders, especially as we come out of the pandemic. Which could be a year and a half from now, who knows. It's going to continue to be important to focus on crowding information, even beyond just during this time where it's important to maintain our social distancing. And it will be particularly important for those of us who are not as well off and rely on the public transportation and seamless public transportation to move around their cities. So I want to remind everyone that we are recording this and we'll be following up via email with takeaways. We really appreciate all of the time that you've taken here today. We hope that you have a wonderful rest of your day, and to reach out to any and all of us with further follow-up questions about your organization or agency. Thank you so much.